Hello students, today's agenda is to check homework. We'll be learning about piecewise functions and you will be able to do 6.6. Today students will be able to graph piecewise functions and describe their end behavior. And we'll be working with different graphs for our assignment, but I'm giving you an example of some of the graphs that we have done in the past. If you do need to review those, you can go back, or you can use technology as well to graph those if that's okay with your teacher or professor. Ask them if that would be okay. So in here it says sketch a graph, describe the end behavior. And in here you have three different functions, and you have y equals negative x minus 2, y equals x squared, and y equals x plus. Sometimes they write it like this: f of x equals negative x minus 2 if x is less or equal than negative 2. X squared if x is greater than negative 2 but less than 2. X plus 2 if x is greater than 2. So a lot of things that we need to review, but I'm going to be saying them as we go. And so one of the things that I recommend when we're doing piecewise functions, it means piecewise because it's made out of little pieces, and it's because you have different functions. So what I recommend is that you use a pencil first, and we're going to be erasing some parts of it. And so for the first equation or function, it's a linear function. This is always in a linear function, the constant is the initial point. And so negative 2, it's right here. It's always on y, on the y-axis. If it's negative, you go down. If it's positive, then you go up. Then this is going to be my slope. Because it's negative and it doesn't have a number, we always need a fraction, so it's negative 1 over 1. From this point, what that means is that it's going to go down one space and one to the right. One down space and one to the right. One down space and one to the right. So this is my rise, is negative, so it goes down. This is my run. Since it's positive, it goes to the right. So that's why from the initial point, we went down one, one to the right, one down, one to the right, one down, one to the right. And so my graph would go like this. However, we have these constraints. And I'm going to do it lightly. Constraints, and it says that we're going to have that line if x is less or equal than negative 2. X or x at negative 2 is right here. That means, and it has the equal, so we're going to include that point. What do we have to do? Now we can highlight the real part. Less means on the smaller side. Less than negative 2 is on this side. So that means that from here on, it does not exist. Okay, so now we can highlight the real part. It includes this negative 2 because it has the equal. And then we highlight this part. And it will continue on and on forever on that side. But what do we have to do? We have to go back and start erasing that part right there. That's not part of our graph. It's only that section from here and on. The next part says that you have x squared between negative 2 and 2. Remember that when the x is in here, it says between those two numbers. Or you can also say when x is greater than negative 2, so from here on, and x is less than 2. So we have to graph the points for x squared, but only between those two constraints. Okay, again, I'm going to use my pencil. X squared just means when x is 0, x times x is 0. Then when x is 1, 1 times 1 is 1, so my y is going to be 1. When x is 2, 2 times 2 is 4, so right there. It does not include the values for x2, so in that case, that's going to be an open circle. And that's going to be my limit, so it goes up to there. On the other side, when it's negative 1 for x. I plug it in and -1 times -1 becomes +1. Then the -2 times -2 is +4. So right there, again, because it doesn't include and it's already at -2, I'm going to have an open circle and I can now connect my graph. Something like that. So those are two pieces of the function. That's why it's called piecewise function, because it's made into pieces because of the constraints and the different functions. Okay, for the last one, again, let me grab my pencil. The initial point is at 2, so 1, 2, it's right there. Then the slope, it doesn't have 1, but we know that it's 1 over 1. So put 1 over 1, put the dot. 1 over 1, put the dot. 1 over 1, put the dot. 1 over 1. That's my slope, okay? You go 1 up and 1 to the right. However, look what it says in here. If x is greater than 2. So that means that I don't even need to align it. I can just say, oh, graph from there. Also, if you see, it doesn't have the equal sign, so it's still at 2. It's going to be an open circle. So if you had the equal sign in here, I said it's like a little pencil. Just you have the little pencil to close the circle, to put more ink in there, but it doesn't, so it's still gonna be open. And you're just going to, greater than that, it's the graph continues on that way. Okay, and I can erase the rest. So this is how my piecewise graph is going to look. The next thing that it says is describe the end behavior. It always starts as x approaches, let's start with the negative infinite, right? When we go infinitely on the negative for x, comma, f of x. And what's happening to f of x? F of x refers to y. What's happening to y? One thing that we need to remember from the previous lesson is that the end behavior, we don't look at what's going on in the middle of the graph. It's just the tails, right? At the end. And so right now we're just looking at what's happening in here. Let me go to the graph. And so we don't care much about what's going on in the graph, but let's look at the tail. The tail tells me, oh, it's going away from x, it's diverging. And the other thing that we need to know, is it going towards the positives or towards the negatives? So in this case, it's going towards the positives on y. So we say, as x is approaching negative infinite, f of x is approaching positive infinite because it's going up to the positives on y. Okay, okay, now what about, oh, and we say that it's diverging. As x is approaching positive infinite, what's happening to f of x? Again, we don't care as much about the middle, it's just this tail right here. So let's look. What's happening? Again, it's diverging, it's going away from x, right? It's increasing on y. It's also pointing up, meaning that it's going to the positive infinite. And it's also diverging. Okay, diverging, it just means getting away. Converging, it means approaching or getting close to a specific number. And with this, we end our lesson. If you can please support the channel by giving us a thumbs up, subscribing around here. This will be the link to the entire unit. Here you will find the next lesson. Also share with those who will benefit from learning math. Now you're able to do 6.6 and have fun.